Okay, a bit more year-8 algebra then, and we're now looking at equations. You should be able to form an equation with one unknown and solve it by observation. Make and solve an equation for the following statement. I think of a number and I add 4 and I get 7. So I'm going to call my number x. I know that seems weird, but that's the way we tend to do things here in math. So x plus 4, so x, I think my number is x, I add 4 and that equals 7. That means in this case that x must be equal to 3. Let's go for a number here again, so we're going for x. If 3 is subtracted from the number, so that's x, then take away 3, I get 9. So some number take away 3 gives me 9. That must mean then that x must be 12. 5 times an unknown number, what do you reckon? Good old x, times by 5 equals 45. So some number times by 5 gives me 45. That number, of course, then must be 9. I think of a number, I multiply it by 4, and then I add 7, and the answer is 55. My goodness. So I think of a number, I times it by 4, and I add 7, and the answer is 55. Let's tidy this one up slightly. We know x times 4, that we write as 4x. So 4x plus 7 equals 55. Now we have other ways of solving that, and if you look further on this video we'll kind of come up with a wee new way of solving it. But if we're added 7, if you take away 7 there, that means the 4x's must give me 48. So 12 I think is going to work. Let's try it. 4 times 12 gives me 48 plus the 7 then gives me 55. As I say, if you don't understand that, watch further on in this video and that'll explain then, because we're coming up with a new wee method then for doing this one. Alright, solving equations. When we're asked to solve equations, we try to get the unknown to one side of the equal sign and the numbers to the other side. To do this, we perform the same operation to both sides. Solve the following equation with one operation. Sometimes this gets set up a bit like a seesaw. I'm going to do it just for the first one, because this here means, you guys used to know it in primary school as that's where you put the answer. You do something here, you work it out, you put the answer here. But what it means is everything on this side is exactly the same as everything on this side. So it works like a balance. So if we have 8 on this side, so there's 8 wee boxes there, and we have 4, and then an x, and we want to know what size the x is, we can do it like that. Now if I take these off here, this one, it'll always drop like that. That's the way a seesaw works. So if we take something off one side, I've got to take it off the other. So if I take 4 off this side here, to keep it balanced, which it is, I need to take 4 off the other side. Now we're not worrying about moments or anything kind of crazy here. And so in that case, then we're going to go x is 4. So here's how we do this. We write x plus 4 equals 8, and we do a line then down each side. And what we do to one side, we do to the other side. What did I do? I took 4 off this side and I took 4 off this side, so I write minus 4, and I write minus 4 here. X plus 4, take away 4, gives me x. 8, take away 4, gives me 4. And some teachers like you to keep the equal sign in line. I haven't got it quite in line there, but hopefully you'll forgive me for that one. A plus 1 equals 5. Don't know if you can see what we need to do to both sides. We eventually want to get the a on its own, so there's a 1 here we don't want, so we're going to take it away from both sides. If I take away 1 from this side, I get a. If I take away 1 from this side, I get 4. Y plus 6 equals 11. Just looked at the right time there. Y plus 6 equals 11. Can you see what it is we're going to have to do? We want to try and get the y on its own. So we're going to take away 6 from both sides. And we're going to have then y on this side, because we've taken away our 6, equals 5. So then we'll draw a few more of these while we're at it to save me the time. So the next one, what does it say? X plus 8 equals 5. Slightly strange one, but we should be okay. So it's x plus 8 equals 5. We want to get, I know the 8's bigger than the 5, but we want to get rid of this 8. We want to get the x on its own, so we're going to take away 8 from both sides. Take away 8 from here, we get x. Take away 8 from here, 5 take away 8, so it's actually going to be minus 3. C plus 10 equals 2. Take away 10 from both sides. C equals minus 8. T minus 3 equals 5. Now you would think take away 3 from both sides, it's not going to work. Now if I take away 3 here, I end up with a minus 6. So if it's a minus there, we actually have to add 3. Oh, you can't see it. Sorry, I'll say that again. T minus 3, you kind of think you might want to take away 3 from both sides, but as it doesn't work, because that would give me a minus 6 there. So if it's a minus there, you sort of do the opposite. So we're going to add 3 to both sides. If I add 3 to this side, I just get T. If I add 3 to this side, I get 8. And 8 is the number that makes this work. If I exchange my T for an 8, then this one works. The same with all the ones above. 8's the only number in the whole wide world that makes this equation work. We have b minus 2 equals 6. So we now need to add 2 to both sides. And we're going to get, I'm sorry, to do my b over here. b equals 8 again. And again, 8 take away 2 equals 6. So b was indeed 2. Again, if you check any of the other ones here, minus 3 plus 8, that does give me 5. So they do all check out. But that's our method. These ones seem incredibly simple. I have a young son, he could work any of those out in his head, but once you get onto the harder ones, we need to have our method down so we know what it is we're doing. So we need to stick with this method for anything else that we're doing. Let's keep going then. I'm going to leave a bit of space down here, but we'll be alright. So 4 equals v plus 2. Bit of an odd looking one here, that's why it came towards the end. So why have we been asked this one? We want to get the v on its own, so we're going to take away 2 from both sides because there's an added 2. If we take away 2 from this side, we get 2. If we take a 2 from this side, we get v. What I want to see you writing though is your final line then is v equals 2, so we change that round then at the end. Bit of an odd one here as well. 3.2 equals x minus 1.6. So we have a minus 1.6 here that we don't want. So we need to add on 1.6 to both sides. If I add 1.6 here, I get 4.8. If I add on 1.6 to this side, I just get x. Unlike the last one, I write it out then properly. Getting a bit shy for space here, but we should be okay. We have 3x equals 9. This is a new one. If I take away 3, this doesn't work. So I have 3 x's, but I want 1x. So I'm going to divide both sides by 3. If I divide 3x by 3, I get x. If I divide 9 by 3, I get 3. And of course 3 is the answer to that, because 3 times 3 does indeed give me 9. Finally then, I have 8x equals 5. I'm going to divide then both sides. I have 8 times as much as I want, so I'm going to divide both sides by 8. This is quite a complicated one here. I can write then 5 divided by 8. And my way of writing this, if we take this over to the side, again this is a terrible working out, but that's okay. We can write then as 5 over 8, or 5 divided by 8.